In this session, we will discuss about distributed file systems. We will discuss in brief about file server interface, directory server interface, and semantics of file sharing. To start with, in a distributed system, it is important to distinguish between the concepts of the file service and the file server. The file service is the specification of what the file system offers to its clients. It describes the primitives available, what parameters they take, and what actions they perform. To the clients, the file service defines precisely what service they can count on, but it does not speak anything about the implementation. In effect, the file service specifies the file system's interface to the client. Now let's talk about a file server. A file server, it is a process that runs on some machine and helps to implement the file service. A system may have one file server or several. In particular, they should not know how many file servers there are and what is the location or what is the function of each one. All they know is that when they call the procedures specified in the file service, the required work is performed somehow and the required results are written. In fact, the client should not even know that the file service is distributed. Now, the distributed file system has two distinct components. The first one, the true file service, and the second one, the directory service. The true file service is concerned with the operations on individual files, such as reading, writing, and appending, whereas the directory service deals with creating and managing directories, adding and deleting files from directories, and so on. So what do you understand by the term file? What is a file? In many systems such as Unix and MS-DOS, a file is an uninterpreted sequence of bytes. The meaning and structure of the information in the file is entirely up to the application programs. The operating system is not interested. A file can have attributes, which are pieces of information about the file which are not part of the file itself. Typical attributes are the owner, size, creation date, and access permissions. Now, once a file has been created, it cannot be changed, and such a file is said to be immutable. So, immutable file is a file that cannot be modified once it has been created. So, usually they keep on maintaining versions of file. Whereas the opposite to immutable files are mutable files. An update performed on mutable files overwrites its old contents. A mutable file is represented as a single stored sequence that is altered by each update operation. Now, production in distributed system uses essentially the same techniques as in a single processor system. That is, it makes use of capabilities and access control list. With capabilities, each user has a kind of ticket called as a capability for each object to which it has access. The capability specifies which kind of accesses are permitted. For example, either reading is allowed but writing is not allowed, and so on. Whereas an access control list scheme associates with each file a list of users who may access the file and how they may access a file. So there are two users over here and two files. Now this is the capability list of user 1, and this is the access control list, also called as ACL, of file 1. R represents the read operation, W represents the write operation and X indicates no action. Now in this figure, file 1 and file 2 would have the following access control list. So with respect to ACL, user 1 has read permissions for file 1 and user 2 has only write permissions for file 1. Similarly, user 1 has read permissions for file 2 and user 2 has no access permission to file 2. Whereas with respect to capability list, user 1 has read permissions to file 1 and read permissions to file 2. Whereas user 2 has write permissions to only file 1. File services can be split into two types depending on whether they support an upload-download model or a remote access model. Now here we will discuss about the upload-download model. We have the client and we have the server. So in the upload-download model, the file service provides only two major operations, that is either read a file and write a file. Now the first operation transfers an entire file from one of the file servers to the requesting client. So here on the client, the accesses are done on the client machine. And the second operation transfers an entire file the other way, that is from the client to the server. So this model is moving the whole files in either direction. The files can be stored in memory or on a local disk as required. Now the advantage of the upload-download model is it is simple. Application programs fetch the files they require. They use them locally, and any modification done to the files or newly created files are returned back when the program finishes. So in this case, no complicated file service interface has to be mastered to use this particular model. Furthermore, whole file transfer is highly efficient. However, enough storage must be available on the client to store all the files that are required. But in cases when only a fraction of a file is required, moving the entire file can be wasteful. The next model is the remote access model. In this model, the file service provides a large number of operations for opening and closing files, reading and writing parts of the files, moving around within the files, or examining and changing file attributes, and so on. Now here the file system runs on the server and not on the client. So now the advantage over here is it does not require much space on the client machine. As well as also it eliminates the need to pull the entire file from the server to the client. Now let's discuss about the directory server interface. The directory server provides operations for creating and deleting directories, naming and renaming files, and moving them from one directory to another. The nature of the directory service does not depend on whether individual files are transferred in their entirety or accessed remotely. The directory service defines some alphabet and syntax for composing file and directory names. Now file names can typically be from 1 to some maximum number of letters numbers, and some certain special characters. Now some systems divide file names into two parts, usually separated by a period. For example, program.c for a C program or man.txt for a text file. The second part of the name is called as the file extension, and it usually identifies the file type. All distributed systems allow directories to contain subdirectories to make it possible for user to group related files together. Operations are provided for creating and deleting directories as well as entering, removing, and looking up files in them. Normally, each subdirectory contains all the files for one project, such as large program or a document. When the subdirectory is listed, only the relevant files are shown. Subdirectories can contain their own subdirectories and so on, leading to a tree of directories, often called as a hierarchical file system. Now this particular figure illustrates a tree with 5 directories, that is A, B, C, D and E. Now in some systems it is possible to create links or pointers to other arbitrary directory. This can be put in any directory, making it possible to build not only trees but arbitrary directory graphs, which are more powerful. Now the distinction between trees and graph is especially important in a distributed system. The nature of the difficulty can be seen by looking at the directory graphs on these two machines. So here we have two machines, machine 1 and machine 2. So in this figure, directory D has a link to directory B on machine 1. The problem occurs when the link from A to B is removed. So when this link is removed. In a tree structured hierarchy, a link to a directory can be removed only when the directory pointed to is empty. In a graph, it is allowed to remove a link to a directory as long as at least one other link exists. By keeping a reference count shown in the upper corner, of each directory. So in this figure, it can be determined when the link being removed is the last one. So after the link from A to B is removed, the B's reference count is reduced from 2 to 1. However, B is now unreachable from the root of the file system, that is from A. The three directories, that is B, D and E, and all their files are effectively orphans. So this becomes an orphan. So this is a serious problem in distributed system. If everything is on one machine, it is possible to discover the orphaned directories because all the information is in one place. All file activity can be stopped and the graph traversed starting at the root, making all the reachable directories. At the end of this process, all unmarked directories are known to be unreachable. In a distributed system, multiple machines are involved and all the activity cannot be stopped in distributed systems. So getting even a snapshot is difficult in distributed system. A key issue in the design of any distributed file system is whether or not all machines and processes should exactly have the same view of the directory hierarchy. Let's have a look at an example. We have two file servers over here, file server 1 and file server 2, holding three directories. So file server 1 has three directories A, B, C with certain files, and file server 2 is having directories D, E, C with certain files. Now, in figure B, we have systems in which all the clients and other machines have the same view of the distributed file system. That is, if the part DEX is valid on one machine, it is valid on other machine also. We can see in figure C that different machines have different views of the file system. If we consider the previous example, the part DEX might be valid on system 1 but not on system 2, that is not on client 2. There are systems that manage multiple file servers by remote mounting. It is flexible and straightforward to implement, but the disadvantage of not making the entire system behave like a single old-fashioned time-sharing system. Since in a time-sharing system, the file system looks the same to any process as in figure B. So this property makes a system easier to program and to understand. Now let's discuss in brief about naming transparency. Now let's discuss about semantics of file sharing. Now when two or more users share the same file, it is necessary to define the semantics of reading and writing precisely to avoid problems. In a single processor system that permit processes to share file such as Unix, the semantics normally state that when a read operation follows a write operation, the read returns the value just written. So B gets the latest value. Similarly, when two writes happen in quick succession followed by read, the value read is the value stored by the last write operation. In effect, the system enforces an absolute time ordering on all operations and always returns the most written or the most recent value. So we usually refer to this model as Unix Semantics. This model is easy to understand and straightforward to implement. The performance of a distributed system in which all file requests must go to a single server is frequently very poor. This problem is often solved by allowing clients to maintain local copies of heavily used files in their private caches. So if a client locally modifies a cached file and shortly thereafter another client reads the file from the server, the second file gets an obsolete file. So in this case, B gets the old value, whereas client 1 has already modified the file. Now the modified file is ABC, whereas B gets the old version of the file. So there are 4 ways of dealing with the shared files in distributed systems. We have already discussed about Unix semantics in the previous slide. The next one is session semantics. In session semantics, no changes are visible to other processes until the file is closed. Or we make use of immutable files where no updates are possible. So this simplifies sharing and replications. Or we make use of atomic transactions. That is, all changes have the all or nothing property.